Perpendicular lines form right angles. Yan ang pag-usapan natin ngayon dito sa ating matsayang talakayan. Kaya, stay tuned! Hello, grade 8 learners! Welcome back to our channel. This is our second part of the lesson, Conditions that Guarantee Parallelism and Perpendicularity. With the learning competency, determines the conditions under which lines and segments are parallel or perpendicular. Let's begin with perpendicular lines. Perpendicular lines are intersecting lines that form four right angles. Let's consider the given figure. In the figure, we have line AB is perpendicular to line PQ, and it can be represented in this symbol. Remember that the inverted T symbolized perpendicularity. And in the figure, we have here the four right angles. In perpendicular lines, we have what we call perpendicular bisector or segment bisector. It is a line, a ray, or a segment that is perpendicular to the given segment at its midpoint. So let's say we have our figure. We have here our given segment, segment AC, and DE is what we call the perpendicular bisector. So we can say that DE is a perpendicular bisector of AC, wherein DE intersects at point B. So we can now say that AB is congruent to BC. We also have perpendicular postulate. It states that through a given point, there passes one and only one line perpendicular to the given line. The bisectors of the angles in a linear pair are perpendicular to each other. So let's say we have line A. There is only one line through point P perpendicular to A. Now, let's proceed to conditions to prove perpendicularity. To prove that two lines are perpendicular, you must show that one of the following theorems is true. Number 1, if two lines are perpendicular to each other, then they form four right angles. Considering the given figure. So in the figure, if line AB is perpendicular to line CD, then angle 1, angle 2, angle 3, and angle 4 are right angles. Second, we have if angles in a linear pair are congruent, then the lines containing their sides are perpendicular. So let's have our figure. If angle 1 and angle 2 form a linear pair, and angle 1 is congruent to angle 2, then line AB is perpendicular to line CD. Another is we have if two angles are adjacent and complementary, the non-common sides are perpendicular. Considering the given figure, we have here if angle MAH and angle TAH are complementary and adjacent, then MA is perpendicular to AT. Next is we have perpendicular bisector theorem. Any point on the perpendicular bisector of a segment is equidistant from the endpoints of the segment. So let's say we have segment AB and segment CD, which are perpendicular to each other, and then connecting CA and CB. Now, if AD is congruent to BD, then we can say that CA is congruent to CB. Next is we have the converse of the perpendicular bisector theorem. It states that any point equidistant from the endpoints of a segment lies on the perpendicular bisector of the segment. So let's say meron tayong segment MN, and above it we are going to draw a point which is equidistant to point M and point N, and we call it as point P. Now, we are going to draw a segment from point P which is perpendicular to MN, and we call it as segment PR. If P has the same distance from point M and point N, in other words, if PM is congruent to PN, then we can conclude that segment MR is congruent to segment NR. And the last one, we have perpendicular transversal theorem. It states that on a plane, if a line is perpendicular to one of the two parallel lines, then it is perpendicular to the other. So let's consider our figure. So in the figure, if line T is perpendicular to line K and line K is parallel to line L, then we can also say that line T is perpendicular to line L. Now, let us use those theorems in solving for the value of x. In the given figure, line S is perpendicular to line T. What do you think is the value of x? Correct. The value of x is equal to 90 degrees. Why? Because if two lines are perpendicular, then it will form 4 right angles. Next example, so we have here, line S is perpendicular to line T. At meron tayong dalawang angles formed with these two perpendicular lines. So yung unang angle, we have x degrees, and yung pangalawa measures 50 degrees. Now, we are going to solve for the value of x. Since sabi natin that these are adjacent and complementary, so we have our equation as x plus 50 is equal to 90 degrees. Since sabi natin they are complementary. So combining similar terms, we are going to combine 50 and 90. So it will give you 90 minus 50. And the value of x is now equal to 40. Next example, so we are going to consider the given figure. Sa given figure, makikita natin that there are two angles which are adjacent and at the same time complementary. So when we say complementary, the sum of the two angles, let's say x plus 20, yun ang measure ng isang angle, and yung pangalawang angle is x. So the sum of these two angles is equal to 90 degrees. So we come up with the equation x plus 20 plus x is equal to 90 degrees. Now, combine similar terms. So we will have x plus x is 2x, and then 90, ilipat natin yung 20 dun sa kabila to combine with 90, so minus 20. So 90 minus 20 is equivalent to 70. Since meron tayong 2 dito, we are going to divide both sides of the equation by 2. So therefore, the value of x is equal to 35. And now it's your turn. Get your paper and pen and do this activity. So you are going to solve for the value of x. And that's for today, guys. Do not forget to like, subscribe, and share. Again, this is Teacher Dali na nagsasabing, practice makes perfect. Thanks for watching!